Hi. Okay, I have here electronic load. This is a very powerful electronic load that I bought from eBay, I think. And after working it for not a very long time, I found a problem that occurs. This is the second one that I have this problem. So it is a design issue or I don't know what. So step one is to show you what exactly is the problem, and step two we will try to fix it. I hope I can fix it, and I will show what is actually happening. So first, if we will zoom, I will try to zoom a little on the display of the electronic load. Sorry for the movements, but there is no other way to show it. Okay, so you can see that it is now connected to 12 volts. This is the power of the electronic load, and what we can see here is the current and the voltage that it is set for till it cut off the power, because it can cut off the power at specific voltage. It should, for example, discharge batteries, and then when you get to voltage that you set, it will cut off the power. So the setting is now 10 volts, and now I will move to the current, show you the current. The current is now 1 amp, and I will now power on my Regal power supply. I will put the Regal power supply on higher current, and this will give me the option to see what is happening here. So now the Regal is set to 1 amp, but I will put it at 2 amps, and you can see that it is on by the LED here, meaning it is given at the output. And I will also show you that this is connected here on the input of the electronic load. So when I am activating the electronic load, we should see a current flow of 1 amp, and everything should work smooth. Okay, so now I'm powering it on. You can see the on the right corner. I see I have a focus issue. Okay, on the right corner, and as you can see, the real current is only 0.029, which means it is 29 milliamps and not 1 amp as I said. So this is the problem, meaning the load is not working properly. So now we will try to find why this happens, and we will also try to find how to fix this issue. It is the second time that it is happening, but since this could have current protection and load protection and voltage protection and every protection that you might want, so anyhow what you did, it shouldn't happen. It should stop, it should, I don't know what, but nothing should burn out. What happened to me in this case. Okay, so now, okay, sorry about this. So now let's try to find out what is wrong with this electronic load. So I will put a fluke and put it on resistance, and now let's try to check the electronic load. Okay, the electronic load is working as a MOSFET which give all the current to a load. The load is usually a wire with a few milliohms, and this is how it works. It's a PWM to a very low resistance. We can see here the three connections of the MOSFET. Of course, we have gate, source and drain. Probably this is the gate and these are the source and the drain, because this is power. We can see a wide, I'm not sure that it is connected, but usually it's gate, source and drain. Now let's look at the fluke, the same size, and as we can see, if I'm checking the MOSFET connection, everything is shorted. Everything is shorted, which what I guess it happens, but we didn't see any current. So there is another part that cut the power out, and we have to disassemble the heatsink to get beneath and see what component we actually have. So just a second. This is just a Phillips screwdriver. There is no specific issue, any issue to disconnect it. So let's do it quickly. You should turn it till you hear the clicks. The clicks means that it is disconnected from the plastic beneath this PCB. Okay, so it's now off. This is the MOSFET, this is the heatsink, all what we took out. We have of course some material for let's say conducting the hot from the component to the heatsink. Okay, so I have here a little fuse. I will zoom to it. This looks like a fuse. So now let's measure, and it is disconnected. So at first glance we have a burnt MOSFET and a fuse, disconnected fuse. The fuse reading is probably 10 amp, because this is the limit of this electronic load. I guess this is a slow blow fuse, because it should get to 10 amps, and at 10 amps it shouldn't burn out. Maybe they should have put another fuse, let's say 15 amps, to have some margin before burning it out. Okay, so I will disconnect the MOSFET. I will check, of course, what is the MOSFET number. So the MOSFET number is IRF. It's IRFP 250. IRFP 250. Let's search on Google on the IRFP 250. It's 250. Yes, this is 250 IRFP. So IRFP 250. As expected, this is an N-channel MOSFET with a ID of let's say continuous of 19 amps till it can get to 30 amps, and pulse current 120 amps. So it shouldn't burn out. So probably there is something else wrong with the design of this PCB. And also the voltage is up to VDS to 200 volts, because this unit can handle up to 60 volts, so this is high above, so it should be okay. So we will try to replace the fuse, replace the IRFP. I have something from the Segway boards. I have a more powerful MOSFET. I have a MOSFET that can handle much more current, and the other let's say the other parameter should be okay. So we will try to do it, and then we'll see what we get. So this is an Segway i2 boards. I have here IRFP 260, so it is the same family. This is much more powerful MOSFET. This MOSFET that I'm using, you can buy it on eBay or anywhere on the net. The parameter is same voltage, it is still 200 volts. The current that it can handle is much higher, it's about 46 amps. So this should be more than better, much better than the used one. So I will now disconnect it. The way to disconnect it is usually to apply more solder and then just try to remove it. So I will show the method doing it. So you just apply more soldering. By the way, there is water protection on the board, so it is much better first to remove all these protections that you are seeing now. This is like an epoxy or another fluid to protect against water. So first I'm applying more soldering paste. And now when we have it, there are two methods in order to remove the part. First one is just to catch it from the other side and then have it is hot now, but I'm catching the component, and now while applying heat to two legs, now I'm pushing it a little with my hand, pulling, meaning not pushing, pulling. Gently till it will start to go out. This is a little tricky to do it. Not very simple. Quite hot now. Okay, now it is moving. Not easy to do it. By the way, I now see that I can do it also from the upper side. It is so hard to take it out because it is soldered from both sides of the PCB, and this way it's a little more difficult to take it out. So first rule before removing a component is to add more solder, especially if the board is old. Now when it is too hot, use a tweezer or something to catch it. Also, if you have ability to work with higher temperature in the solder station, it would be much easier to do it. Also, the other message, of course, is to use a solder removal gently. Up. As you can see, it worked. Okay, we'll wait till it gets cold, and of course, after doing such a thing, it is a good thing to check that the MOSFET is still alive, because we applied a lot of heat. We'll clean a little the pins, and now let's connect it to a component tester. It will be difficult because I have to solder wires. The wires are not long enough, so let's do it second. Okay, so I've soldered the component, and now let's test it. As you can see, we have the wire and they are connected here. And let's look at the test on the LCD. So testing, and we can see N-channel MOSFET, 3.8 volt. We have the capacitance and RDS, which is 0.4 ohms, which means this is okay. So the component is working, and now we can solder it to the board. So now let's remove the old MOSFET. So again, I'm doing the same message, applying heat. Now I will use this pump to remove solder. On the other side, after removing, I will apply heat and move it with my fingers. Gently, not to ruin the PCB wires, conducts. It is off now. But be aware that about the gate, source and drain, it was like this. I mean in the pins, and the other MOSFET is the same connection in this way. I have already checked it, so I should put it inside on the same arrangement of pins. little problematic. If you can see that the hole is still not clean, so again, same method, just apply more solder and then we do the same thing again. And now it is clean. So what we need to do now is just put the new MOSFET in. And solder it. Something like this will be okay. Maybe a little more like this. Okay. And now soldering it back. We'll check it from the bottom. Apply more solder at the bottom side. Now, of course, the first thing to check is that we have solved, oh, sorry about this, we have solved the short issue. It reminds that the last was shorted, and as you can see, this is 4 megs and this is open, so it is okay now to go. The last thing is to remove this fuse. I will try to find something similar. Okay, so I found some fuses from a, this is a 9-volt battery. In the battery we usually have inside fuses like we see here, so I will now, I'm sure that these fuses are for sure about 10 amps or maybe more. It is connected directly to the output of the battery, so again applying solder on one side and on the other side. Something like this, till it will be off. Again, a little tricky to take this part off because you have to apply a lot of heat, but at the end it goes out. The size is more or less about the size here. So let's remove the disconnected fuse. Always same message. Get it hot on one side and then on the other side we can see that this fuse fit to this PCB. After applying it, I like usually to hit both sides so it will be a tied to the PCB and not one side is higher than the other. Hopefully it is still connected, the fuse. Okay, it is okay. I will put the flux so we will be able to see it. Just a second. Okay, so you have here also the fluke, and when I'm touching the fuse this is 0, which means it is okay now. So now we have to connect everything back together. We have this plastic, the plastics that go like this, I think so. So first this was this way, something like this. It touches the heatsink, okay. I mean the heatsink touches I think it should be like this. Yes, this is the correct size. Yes, so now this should be like this, and this gently should be connected like this, connecting back everything together. It's a good thing to take the screws not ones that near each other, but the one that is not near the other, to apply force with the correct way. Okay, there are a lot of noises. Don't forget to connect the fan back. And now I need to do last check to see that we are not shorted, and we are okay. So now let's repeat the tests that we started with to see that the problem is solved. Okay, so now let's do the test to check that everything is okay. So the setting is saved on the electronic load. Also make sure to connect the polarity in the correct way, because there is a polarity. Now I will power on the power supply and will power on. Okay, and we can see that the problem is solved, because we can see on both, on my Regal, that the current now is 1 amp. You can see also that it is quite accurate, 1031, and on the electronic load it's almost the same current. So the fix that we have done is working perfectly. Okay, hope you enjoyed, but I think there is a design issue with this load, because it shouldn't happen, and I will try to see now what is causing the problem. Thank you and bye.